and integrating habitat into farming systems, recognising beneficial insects and so on. So I'll hand over to Barbara Smith from Coventry University, who is our chair.
Thank you very much. So welcome to this session on how we can build pest resilient systems. It's a very important session. From those who listened to Michael Gove yesterday, you can see it's even reached the lofty heights of the Secretary of State for the Environment, that we need to manage pests more sustainably. So although the total weight of pesticides that we use in the UK has halved since 1990, the area that we treat has increased, and so has the toxicity. And some crops can receive maybe 20 different active ingredients. So there's a real need for us to be looking at different ways of managing our pests. And over the same period that these pesticides have been increasing, there's been a significant research into how to build farming systems that are resilient to pest attack. And that's what this session is about. So we're bringing together 3 speakers who are going to talk about how this can be done in practice. So what I'll do is I'll give you a little bit of background to the 3 speakers. And then each speaker will speak for about 10 or 12 minutes. And after that, we'll have a wider discussion session. So we have with me here Charlotte Rowley, who's from the AHDB, who has, at the beginning of this year, became a crop protection scientist at AHDB. She did her PhD at Harper Adams in agricultural entomology, and she's responsible for managing a number of pest research projects and specialises in insect pests in the arable sector. She's generally broadly interested in IPM. Richard Pyrewell is the science area lead for sustainable land management at the Centre for Ecology and Hydrology, based at CEH at Wallingford. And he's a leading expert on the delivery of knowledge-based solutions to conserve and restore biodiversity, natural resources and ecosystem functions that are responsible for human well-being and livelihoods in semi-natural and intensively managed habitats. And I know that he's worked on a range of systems, heathlands, grasslands, and agricultural habitats, and has been very influential in the development of agri-environment schemes. And our third speaker is Julian Gold. Julian Gold is a farmer who manages 800 hectares in Oxfordshire on a 5-year rotation of oilseed rape, winter wheat, spring beans, winter or spring barley, and has recently integrated a sheep enterprise. He's passionate about sustainability and soil health, and he's part of the ASSIST trials working with CEH. And he's been experimenting with permanent legume understories and trying different clovers. So we're looking forward to hearing about the experiences of our 3 speakers. Welcome, and thank you for coming. And so I'd like to begin this session by introducing Charlotte Rowley from the AHDB.
It's not working. Oh, there we go. Hi everyone, I'm Charlotte from AHDB, and today I'm going to talk to you about the principles of biological control. So I'm taking it back to basics really, but hopefully it'll act as a bit of a refresher. So what is biological control? Well, obviously it's using living organisms to suppress pest populations. Going up a level is part of integrated pest management, which is essentially using lots of different tools to manage pest populations. IPM generally doesn't exclude pesticides, but considers them as a last resort. So I think of IPM in these 3 stages. First of all, prevention, so keeping pest populations below damaging levels. Evaluation, if an outbreak does occur, assessing the risk to the crop and the potential financial loss, and making a decision as to whether control is necessary, and control is the final step and might be biological, chemical, physical. So obviously biological control fits into the control element of that, but it's also used in the prevention element to maintain pest populations below damaging levels. It's important to note that biological control can't be used in isolation, as anything in IPM can't be used in isolation. It all needs to work together. And every other aspect of your IPM program needs to be compatible with other aspects. And that's especially important with biological control. Oh, sorry. So there's three main forms of biocontrol: predators, parasites, and pathogens. Today I'm going to be talking mainly about predators, but they all have one thing in common, and that's they're all living organisms. They all have very specific ecological requirements, and it's important to take those into consideration if your biocontrol is going to be as effective as it needs to be. So there's two main types of biocontrol used in agriculture generally. First off, we've got conservation, which is mainly used in open field situations, and this is building habitat and resources to support natural enemies and to draw in natural populations of insect predators and parasitoids into your existing crop. The second route is augmentation, which is generally used in glasshouse situations or protected cropping, and this is where natural enemies are specifically brought in and released en masse into a system to manage pest populations. So in terms of biocontrol as it's used today, it's far more commonly used in horticulture, in protected cropping, because it's sort of an easier system to manage, because obviously you've got controlled conditions, you've got a limited number of predators and pests coming in. So I'm going to talk a bit about the open field situation, which is obviously a lot more difficult to achieve because you've got so many variables, you're dealing with natural populations, and I think sometimes it's difficult for growers to understand if what they're doing is worthwhile. And part of that is actually knowing what you're looking for. So I'm going to go back to basics and go through some beneficial ID now. Just talk to you about some of the natural enemies that you want to be encouraging into fields. And if you're not a farmer, then look out for them in your gardens as well, because it's all applicable. So starting off with beetles. Beetles are an amazing natural enemy. Obviously, ladybirds are really recognisable. If you've heard of the invasive harlequin ladybird, that was actually introduced into Europe as a biological control agent. Because of its ability to consume massive amounts of aphids. So they are actually really effective predators, and the larvae, which is up there, are also really good predators as well. Ground beetles, or carabids, are really mobile, effective predators. A lot of them are highly generalist, so they'll eat a lot of pest species. Some of them are omnivores, so they'll also eat weed seeds, which is quite handy. They're the ones that you sort of see scuttling along the ground. They don't generally fly. They're normally like black or shiny or metallic, quite chunky beetles. And they have soil-dwelling larvae, which is in the corner, that also are effective predators and will go to town on your soil-dwelling pests. Similarly, rove beetles, there's loads of different species of these. They're often mistaken for earwigs because they're quite elongated in their abdomens, but they don't have the pincers that earwigs do. They're really good predators, generalist predators, and have soil-dwelling larvae as well. In terms of flies, we've got hoverflies. So hoverflies are amazing pollinators. They're really mobile. They can fly long distances. The adults feed on nectar and pollen, so they'll really benefit from your flowering margins. And the larvae feed on a wide range of things. Some of them have predatory larvae, so this is the marmalade hoverfly, which is really common, and the larvae will feed on aphids. So they're a 2-for-1, really. A lot of hoverfly species are bee mimics, so they're often confused with bees, but hoverflies have just one pair of wings compared to bees, which have 2. Hoverflies have the big compound eyes that are typical of flies, and they also have really short antennae, so you can tell them apart if you can get close enough to see them, and also the typical hovering flight. So on the next slide, I've got a spider warning, so if there's any arachnophobes, do look away now. So spiders, amazing natural enemies. Typically on agricultural land you'll get wolf spiders, which are really quick, they've got really good eyesight, so they're really good predators, highly generalist. You can look out for them sunbathing in open ground in the spring, and they're active throughout the year, which is really useful, not just summer visitors. You've also got money spiders, so these are the tiny little spiders, but they can often be found in really high numbers, and they disperse through ballooning, so they get caught up in the wind and they spread the web out behind them, and that forms these huge sheet webs across a crop. So you'll often see this in autumn on sunny mornings. You'll see a whole field full of silver. This is from money spiders, and so they're really effective at trapping flying insects. And they benefit from a lot of plant architecture in the field. So if you're leaving stubble in the field, or if you've got cover crops over winter, they'll really benefit from that for their web formation. You've also got harvestmen, which aren't spiders, but they look a lot like spiders. They've got really spindly legs and tiny, non-segmented bodies. That's how you can tell they're harvestmen. And some of those are predatory. And then you've got these guys, which you can actually buy for horticulture situations, but they're also present in natural populations. So lacewings obviously have the character